Okay, well, it's just about 9 o'clock, and I apologize for all of you who are still eating breakfast and have to look at my face first thing in the morning. Try to keep it down. You'll be all right. Especially this guy. Look at this guy sitting right in the front here. Paul. Okay, so everybody, welcome. I hope you're having a great time at the conference. Is this anybody's first time in Philadelphia? Pretty cool. How do you like it so far? Yeah? Good. Yeah, tons of awesome food here, tons of history. Very, very cool place to be. All right, so we're going to go ahead and get started. My name is CF Grugan. I'm a user experience design technologist for Comcast. It's a lot of fancy words that basically mean I am a graphic and user experience designer who is also kind of gifted in doing codes pretty all right. All right, so I'm relatively new to the role of this UX design technologist. Before that, I was working as a web developer with the Xfinity Home team at Comcast. And if anybody saw the Polymer talk and workshop yesterday, I worked very closely with Chris Lorenzo. We used Polymer to build out the entire web portal. And that was a super fun project. But today's project that I'm going to be taking you through is something I've been working on for a little while. And we're going to put together kind of this really basic Alexa clone using Node.js and Edison board, IBM Watson, and DuckDuckGo's Instant Answer API. I found this originally as a tutorial that was on Losant back in like May or June. And I took the tutorial a little bit further, added an always listening and wake word component to it, so it didn't have to be a button press flow. Also, I'm going to show you guys some of the stuff that was missing from that tutorial a little bit, like how to actually set up the Edison board, how to set up configuration for it, put it together physically, and tie into IBM Watson's service. Okay. So why did I get interested in looking into a project like this? Internet of Things, it's a huge buzzword right now, right? And I had worked a little bit with it on the periphery while I was on the Xfinity Home project, where I was basically on the team that was making an interface that could control and receive information from smart internet connected devices. But I really wanted to get my hands a little bit more dirty and get into the weeds of figuring out different network services and how they could interplay with physical devices in the real world. So here is an obligatory block quote for any tech conference talk. This is from Jared Newman of Fast Company. He says, connected devices will have a major impact not on just homes, but businesses. And just like any company that blissfully ignored the internet at the turn of the century, the ones that dismiss the Internet of Things risk getting left behind. And I think this really kind of sums up a great opportunity for all of us as developers to advance our skills early with playing with internet-connected devices, if we haven't started already. I think it's really going to help keep us all relevant in a huge space that is still exponentially growing. And let's just, kind of slow down a little bit, because yeah, it's a buzzword, right? People get very excited about it, but let's just take a step back and see where it really falls in on this Gartner chart. Does anybody pay attention to this Gartner chart every year that comes out, gets released? I just found out about it a couple months ago, and I think it's fantastic. Basically, these are all like corporate tech buzzwords, right? That are plotted out on this chart. The X matrix on here, the X value is, kind of period of time, and our Y value is like the level of expectations on this. And up at the very peak there, we have Internet of Things, all right? So that is the peak of inflated expectations. So yeah, it is a very heavily talked about thing right now. I think a lot of people who talk about it might not fully understand it yet. And as with many of these, tech buzzwords, and after people start to fully understand it, we go into this trough of disillusionment. Right now, augmented reality is getting ready to bottom out. Cryptocurrency exchange is bottoming out in that right now. And all the way at the end, we have enterprise 3D printing. So that's getting into the plateau of productivity. That's when something's really viable and people can make money off of it. But yeah, Internet of Things, where that falls on here, is up at the very top. So it is right at the peak of inflated expectations right now. Okay, that's great. But why else did I do this? So I discovered something along the way while trying to tackle this project. And it's one of the things that I'd like you all to take from this talk, and that is how incredible some of the services are out there. I didn't know how easy and how free it would be to tie into IBM's Watson text-to-speech and speech-to-text module. Not to mention, I mean, DuckDuckGo's Instant Answers API, it's really, really easy to integrate with. They don't have, you know, the biggest data set that is supported by the Instant Answer API, but it is quick to implement. You could probably do the same thing with Google or Bing, which will probably be my next version of this, just so when I ask this thing a question, it has access to a lot more information. I made a Node.js app that runs on an Edison that will, using just 200 lines of code and these services together, make something that's pretty fun to play with and pretty interactive. And the reason why I can write an app that's only 200 lines of code with comments is really because these services are out there and available to us that we can interact with. So if you haven't played with any of those services like that, I highly recommend looking into it and just, you know, try to build something. Just have some fun with it. So here's what is needed to actually get this project underway. You're going to need the Intel Developer Zone, which is a good reference for when working with the Edison. You're going to need a Bluemix account. That is going to be necessary for setting up your app, as well as tying in the speech-to-text and text-to-speech modules, and getting the credentials for those that you can, you know, pop into your app so you can make your requests and everything's good. An Intel Edison, which I have sitting here. I can't pick it up too much right now because it's really wired in. And I use the mini breakout board, which is pretty small because I wanted this to be a real small form factor. But you can do this just as easily with the full breakout board. You're going to need a small micro USB microphone, a Bluetooth capable speaker, and an IDE of your choosing. At first, I was using Intel's recommended XKD text editor and environment. You can also deploy straight to the board through there over serial connection or SSH. But I ended up switching over and just, you know, I'm a creature of habit and I love Atom, so I used Atom, worked on my app that way, pushed it up to GitHub, SSH'd into the Edison, and just pulled the project down. I think that was just a little bit easier for me. Okay, so has anybody worked with Watson before? I know there was a workshop with it yesterday. If you haven't yet, again, look at it. It's pretty easy to get set up. And it's really powerful, the things that you can build with it. So you're going to need to get set up with a Bluemix account. The two modules that we're going to need are the text-to-speech and speech-to-text modules. There's a lot more in there that Edison can do. Really, really powerful things like Watson Insights you can use to identify patterns in unstructured data. And you can recognize a person's mood based on their tone of voice with another module. These examples are pretty complex, and those services aren't really free. I think it's pretty affordable, especially if you're just building like a little prototype app, and it's based on how many requests you have per month. But the text-to-speech and the speech-to-text are free as long as you stay under a certain threshold, and I'm not sure what that is off the top of my head. Okay, so we've got our Bluemix account. Now we need to create an app inside of Bluemix. And make sure to include the speech-to-text and text-to-speech services. Then we go into getting credentials. Lost my spot here. Okay, oh, yes. I don't know if anyone else has ever run into this before, but I'm a little bit wet behind the ears when it comes to development sometimes and like hosting projects and pushing things up on GitHub, but never, ever, ever post like app keys, secrets, or credential information on your GitHub account. I one time posted an app that was working with AWS for image storage, and in about half hour, some helpful friendly robot out there decided to steal my credentials that run GitHub and racked up a $20,000 bill on AWS, which was awful. They called me. Oh yeah, it was great. They called me, we got it all straightened out, they were very understanding, and they did not actually hold me accountable for the $20,000 bill. What's that? It was you! See me after class. So yeah, you're gonna get your credentials, you're gonna use them just as like a credential object. You can put them right inside of your app and get access to it that way. Hide them in a config file, obfuscate them, whatever you gotta do. Okay, so now it's time to actually put the device together. Anybody ever play with Edison before? Guys, you gotta do it. It's incredible. How about Arduino? Yeah, Adafruit, Featherboard, stuff like that. Okay, you can get a lot of functionality out of that, but the Edison is really, really powerful. It's gonna give you Wi-Fi, Bluetooth, all the good stuff. Highly recommend it. It's fun and pretty easy to work with. And I'll just take a few minutes to show you how the Edison gets attached in the next couple slides. But it's great because, I mean, you can run Arduino on the Edison, you can run Python, Node.js. I'm sure there's more, but those are the three that I had prepared for today. So when you get your Edison, and if you order it with a mini breakout board, this is what you get. Down at the bottom is the mini breakout board, which gives you your I/O pins. And then the actual Edison chip itself, which is up in the top right, and these two little tiny stainless steel nuts. All right, so you're gonna take the Edison, put it on top of the breakout board, making sure that the bolts on the breakout board line up with the diagonal holes on the Edison, and see where this thumb is in the bottom right here. That's where you're gonna push down until you hear like a nice little click. Not an awful click. If you're an awful click, you're the Hulk and you squeeze too hard. So this is how you attach it to the board. Then you're gonna secure it in place with the two supplied nuts. And then you're gonna plug it in. So you're gonna take two mini micro USB cords. One is for power, one is for data transfer. Then connect that to your computer. You should see the green LED light come up to indicate a proper power connection, letting you know that the board is getting power flow through the entire thing. Oh, yes. Then you have to download the Intel Edison board configuration tool. You can flash the firmware through this. I'm not sure if there's a way to do this through the command line because it's hard to get access to the board if the flash or the firmware is not up to date. But you can get the latest firmware from Intel and put it onto the board using this tool. I usually have to do it like every couple weeks just to stay up to date. Okay, so now we've got the Edison pretty set up and we've got it connected to our computer. We need to start to give it a little bit of an identity, do some configuration. So you can do this by connecting to the Edison over USB serial at first. Once you have your serial data port connected in, you're gonna go to your console and type ls root dev cu.usb serial -star. That's gonna return you a list of all USB serial connected devices on your machine. And what you'll need to pay attention to is the number that comes up after USB serial dash, because you're gonna need that for the next step. You're going to take the number that you got from the lookup, you're going to go into terminal, you're gonna screen into it over a baud of 115200. So it's gonna be cu.usb serial dash, the number that identifies the actual device, and the baud rate. And now we're gonna go into the configuration workflow for the Edison via command line. So this next step, configure Edison with a flag setup, is going to enter you into a workflow where you can add your Wi-Fi network information to the Edison, so the Edison can connect to the outside world. And you can configure your Edison board with a name. You can name it and give it a password to kind of lock down dev access to the chip. After that, we have to go in and start giving this thing a voice. So we've got the chip configured, and we can either continue to work serially through USB, but now that we've given it Wi-Fi credentials and it's hooked up to our home network, might be easier just to SSH into it, which is, I think, a lot easier. So let's start by getting Bluetooth set up on the chip and connected to the speaker, right? So this is going to enable the device to speak to us. All right, this is the hardware that we need. So the first thing we're going to do is get into the Bluetooth control on the Edison board itself. We have to unblock Bluetooth first, then we can get into the Bluetooth controller. Then we tell it to scan for devices. That'll start just showing a running list of all devices that are accessible to it at the current moment over Bluetooth. You're going to find the speaker that you're using in that list. It should be pretty easy to identify because everything should have a name with it. And then you're going to pair at your speaker's address and then connect at your speaker's address. And then you're going to quit out of Bluetooth. Okay, so now that we've given it a voice, we need to give it a way to listen to us, which is really, really simple. I just have this little tiny USB microphone that runs right into micro converter that hooks right into the side of the mini breakout board. So once I have that connected to the breakout board, I can type a-record-l. That's going to list out all of the audio input accessories that the Edison is currently recognizing. And we don't need to do too much else for setup for that. We just need to pay attention to the device number that comes back and the card number, because we're going to need that later when we're writing our Node app. Which brings us to the good stuff, JavaScript, right? Okay, so I'm going to walk you through all the steps to getting this Node.js app to do what we want it to do with the hardware that we've provided it. So we're going to set up an always listening flow to listen for a wake word. We're going to capture 5 seconds of an audio clip. We're going to convert that audio into text. We're going to perform a search on that text using DuckDuckGo's Instant Answer API. And then we're going to convert the response from that to audio and play the audio back over the USB speaker. Here's the credentials that we're going to set up for our text-to-speech and speech-to-text service. I'm also using Watson from the NPM registry to get access to those methods. Okay, this here does a little bit of setup to add some params to the request that we're going to make to Watson. It also initiates a GStreamer child process to play the audio that we pipe to it that we get from our response from Watson's text-to-speech API. Now, the other side of the coin, we have to convert speech to text. It's similar that we create a G process for a-record that's going to record an audio file and store it temporarily. Then we're going to take all that information and we're going to send that file out to Watson, the response of which is going to give us, its best guess at the text that it heard in that audio file. And then we can use that text to try to play to execute the search on DuckDuckGo. This is our actual search method. This is going to take the query that comes back from Watson. So if I say cat, Watson's going to return text that says cat. We're going to take cat. That becomes the query that we pass into our request against DuckDuckGo. This is a method that is just going to play a WAV file for us. So we already have our speaker set up over Bluetooth. And it's, oh, I'm sorry. Yes, it is. So this is going to actually play the wave over WavePosh through the Bluetooth speaker. And then this is our main little function here. I'm using Waterfall here to, first I have like a privacy flag that I have set up. So if I don't want this thing listening to me all the time, I can toggle that back or forth. And also this waterfall is really kind of the main bread and butter here. We're going to listen, search, speak, and then run our finish method, which kind of just does a lot of cleanup after one successful flow. Okay, so once we have a response from DuckDuckGo, we can take that response, send it back to Watson to convert the text into audio. And that is going to be put into our little speak method here, which we'll call our TTS, or text-to-speech method, which will force it to pipe through and play our response through the Bluetooth connected speaker. Okay, so I was having trouble with the network here yesterday, getting my Edison connected, but we're gonna try to see if this is going to work. Let me see here. Fingers crossed.
Ready.
Okay, so it's letting me know it's ready now. I'm just gonna put my output up on the screen here. So you can see it's listening for 2 seconds, right? And what it's listening for every 2 seconds is for me to say a wake word that I have set up. And you can see that it's actually kind of returning things that I'm saying, but unless I say that wake word, it dumps that audio, starts the flow over again, and doesn't execute a search. So I'm gonna try the wake word out and see how this goes. Jarvis. Hey. Baseball.
Baseball is a bat and ball game played between 2 teams of 9 players each, who take turns batting and fielding.
And this is one of my personal favorites. Jarvis. Puppies.
I'm sorry, I was unable to find any information on puppies.
Not poppies. Jarvis. Puppies.
Nope.
Ah! He's got an attitude sometimes. Let me try this one more time.
Ready.
Jarvis. 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 There we go. Puppies. Do it, do it, do it. Puppies.
I'm sorry, I didn't hear you.
Ah! So you can see, my wife thinks I'm insane because I spend a good amount of time screaming at a computer chip, and that's what she sees. But no, in all seriousness, she thinks it's pretty cool. She's played with it a lot. I think that is it for me. If anybody wants to play with this a little bit later, I'll probably have it set up over in the lounge area. As long as you say the wake word of Jarvis, it should start listening to you, and you can execute a search. One more time here. Jarvis. I still have a lot of bugs to work out. But I mean, you can start to see, using all these free services that are available to us, we can tie in with Node.js, write an awesome little JavaScript application, hit these APIs, and we can build things that we can work with in the real world, which is pretty remarkable. And yeah, I'm super excited about what the next 3 to 5 years are going to bring with the Internet of Things and new services that are going to pop up. I'm sure there's going to be more free services that developers can play with. So long and short of it, look for services, try to come up with ideas, and just build something. Like, buy an Edison board. Do it. I swear, Intel's not paying me for this. I think it's awesome. It's very fun to play with. So my name is CF Grugan. You can find me on Twitter at CheFA. And thank you very much for your time. I appreciate it. Yep. Oh, yeah. Any questions? Yeah.
Interesting things about the text that it returned. Like I noticed that it returned the percent sign.
I saw that too, yeah.
Probably when you said the word I'm guessing.
Yeah, it will actually kind of infer based on some things you say and how you say them, the tone of. So obviously I'm feeling a little hesitant this morning.
And it does that so that it automatically kind of takes that out of the text so that it's cleaner to search it.
Yes.
Is that right?
Yeah, that's part of Watson's process for making sure it's dealing with, the most valuable keywords in what you're saying. Any other questions? Yes.
What services would you want, right? Like you say, go out and there will be these more free services in the future. Like what services would you want? Like what should we go build for you to use?
Ooh.
Using, REST and JavaScript and Awesome.
What do I want? I want a service that will make it possible to have a replicator so I can have my Earl Grey tea hot. That's what I want. I want that service. If you could get me something that would have like the actual chemical composition of all kinds of food, just like as data somewhere. That could be used to you could 3D print food now, and people are starting to do that. It'd be awesome to have a service that would, you'd be able to make a request for a certain type of food. All the data's there, it knows exactly what that food's composed of. Print me out a sandwich.
Here's something
That'd be fun.
I would like, and I think it's going to be pretty easy to do. I'm a bus rider, and I always want to know where the next bus is and what block it's at. And I usually just look it up on the Send app, and they have an API. So I'd like to be able to just ask, where's the next bus, so that I know when I need to leave my house to get to the bus stop. That would be cool.
Nice.
So you have this wake word thing going on. Is that a feature of Watson's API or of your code?
That's my code. I'm just looking for, it's a really, really basic implementation where I'm taking those first 2 seconds where it's in this always listening loop, and I'm staggering that. So I get 3 instances of a 2-second listening loop that are all kind of layered over top. Because if I start saying Jarvis and it cuts off in the middle, it's gonna get jar and then this. So I'm kind of trying to protect against that by having a couple instances of that loop running. That takes the wave file that gets recorded from you speaking through the microphone, and it hits Watson right away to get the conversion to text. And then I'm just doing a simple check to see if it contains Jarvis. If it does, start listening for 5 seconds now and wait for a keyword, execute that keyword out to Watson, get the text response back, shoot that off as a query against DuckDuckGo's API. When you get that back, take that text, pipe that through Watson's text-to-speech. That gives you a wave file that you can play through the USB.
Wi-Fi's already starting to crap out, so my guess is some of your bugs are not your bugs, they're your connection to the
Well, you know what? I couldn't connect to the Wi-Fi at all. I'm actually doing this through James's Android right now, tethering. So I'll blame James. But no, I mean, there's some weird timing things that I have going on right now with the always listening loop, which I need to work through. So I think it's kind of interrupting me as I'm trying to speak sometimes. Also, there might be just a lot of electrical interference with the microphone, 2 monitors here with the actual Edison board. Yes?
You said you were a designer, right? Or
Yes.
Yeah, so seeing this as how you're kind of designing for something that there's nothing really to see, have you found any cool paradigms or approaches you've taken or things you see in the future? Just kind of learning from it as a designer, just any takeaways from that?
Well, I could tell you where I want to get this eventually in terms of a user flow. It's awful right now that I have to say a wake word and then wait for that to recognize that and then start talking. What I really should do with this is I should be able to say, Jarvis, tell me about puppies. I want it to get more of a natural language interface that you can just talk with, right?
Like an intro or something like that.
Right. So if I say to this, Jarvis, tell me about puppies, I should be able to see, hey, Jarvis is in this. Get rid of the, I could take the whole thing to Watson. If I'm using Watson Insights, it's going to automatically identify for me the keywords in there. So it might see Jarvis, it might not. I might cut that out before I send the the request out, but it's not going to care about, tell me about. It's just going to see the word puppies, and it'll return that back to me. So there's a lot of cleanup that could be done with this to make this a much more like natural conversational user interface. But yeah, you don't need any visuals with it. One thing that might be nice is some kind of LED indicator that, hey, I'm listening to you right now, or I'm not listening to you, because people are always scared about their privacy. But yeah, that's kind of the angle I take on it, coming from a UX background. Like, how can we make people not be skeeved out by this? How can we make people trust this? Because until people start trusting it, they're just not gonna, it's not gonna take off. Yeah. Yes?
Can Edison run plug into a power source, and if so, how?
You can hook up a battery to it. You can hook up a 3-volt or a 5-volt or 9-volt battery to it. I'm not sure off the top of my head how long that will actually last with some of the batteries that are out there now, but if you get a nice lithium-ion battery, it could last quite some time.
So I've had a chance to speak to the primary evangelist for the Alexa skill platform recently, and trust is a really hard problem for that. It's interesting that you bring that up. Have you experimented with collecting metrics on failed requests to leave it up?
Not yet, but that'd be, a great way to, like, if I had this as say I have it first as an art installation somewhere, just put it out in the public where people can talk to it, I'd be able to gather some really good information about failed requests, like you said, and use that to inform, future versions of the software. I think that'd be really fun to do. Super useful. Probably gather a ton of user metrics too, that could help figure out this problem of a voice UI. Like, what is it going to be shaped like? What is it going to look like in the future as we're just conversing with machines? Yes?
I think the ideal way to do this is have just a very simple keyword recognition thing that's always listening and runs locally.
Yeah.
Have you looked at anything in that direction yet? Is that even possible yet?
I'm sure that'd be possible. I mean, I could spin up a completely separate instance that just is always sitting there, and it could turn a Boolean to true so that, the next thing that gets listened to just goes.
The problem is how do you do that very simple keyword piece locally without talking to an API?
There is actually a solution out there for that. It's called Pocket Sphinx. Pocket Sphinx is interesting because it's an entire library that can just live right in one unit. You don't have to do any calls for that. And it will try to do some best guess as to what word, what utterance was just picked up here. So you can do it through Pocket Sphinx. And I was trying to play with that a little bit, but I was having some difficulty with it. But that's something I think I should definitely continue on with, because that could make this just a lot more lightweight.
Yeah, I think that could solve both the privacy issue and
Yeah.
the responsiveness.
Yeah, I mean, it gives the user ownership of, okay, I have this device in my hand and anything that I'm saying is staying right here. So, cool. Any other questions, guys? All right. Oh.
What did it actually say respond when you said puppies?
Oh my God. All right. I'm going to hit the DuckDuckGo instant answer because it is, no, I'm going to try to spin it up again because we have time and it is so worth it because the response is great. And it was the first thing I said to it where it worked, and it was just hysterical, and it was such a great moment. Didn't hear the speaker go. Let me just make sure I'm still paired to this. Oh, it already exists. Cool. Okay, so this should work. Okay. Ah, the speaker's not working now. I can, this kind of defeats the purpose, but I can read you the response from DuckDuckGo. It's so worth it to try to get this to work, though. Why won't this talk? Do it. Do the thing. See, this is what I'm talking about with me yelling at computer chips all day. Do it. It's saying the speaker's connected. Yep, already exists. What the what? Oh, there we go. We're gonna try this one more time, guys. Whoop. At least I got it working once for you guys. Oh, wait. There we go. Man. Huh? Turn it off, turn it on. First rule of IT, right?
Windows.
All right. Mm. Do it. Attempting to connect. Okay. Please say ready.
Ready.
Okay. Jarvis. Puppies.
Nope.
Well, recognize puppies.
It did recognize puppies.
Maybe this many times they thought you were DDoS them, they turned off puppies.
Ready.
Jarvis. Puppies.
Nope.
Nope. Oh, come on. One more time, and then I swear I'm done.
Like 20 minutes.
Yeah, we have 20 minutes, we'll watch this all night.
Just look up to the video and see your face.
Ready.
Jarvis. Puppies.
Nope.
I think it's actually, I'm getting a bad request on Instant Answer API right now, actually. Jarvis.
Ready.
Puppies. Yeah, it's weird. I've got an issue where it looks like it's going into like the 5-second listening loop and the 2-second listening loop at the same time. So I've got some like collisions happening there, which wasn't happening with baseball earlier. Jarvis.
Ready.
Puppies. Nope, heard copies.
Nope.
All right. Well, there we go, guys. A whole bunch of nope. All right. Well, thank you again. I really appreciate it. Enjoy the rest of the conference today. Thank you. If you have any questions or you want to play with this a little bit, I'm going to be working on it a little bit in the back somewhere, probably cursing and shaking and a little bit of crying. That's all right. All right, guys. Thank you so much. Enjoy the rest of the day. And there's still breakfast back there. Also, I wanted to mention too, there's a job board in the back. So if you're looking for a job or if you're hiring somebody, definitely take use of that. Lots of good stuff on there. All right, thanks guys.